Hi everyone. Today, this is an exciting day, everybody. This is our last lesson in SNC 2D. So, let's begin, shall we? We're going to be talking about discovering past climates, and the reason we look towards the past is to see if there is any significant change and if in fact the climate change we see now has been seen before, because as in everything, we learn from the past. Okay, so the people or the scientists that study past climates are called paleoclimatologists, and that's a good word to know. Normally, this would have been something on a final exam. So paleoclimatologists. Just to remind you, this is section 9.1 in the textbook. Okay, so we jumped ahead to chapter 9. What paleoclimatologists do what they do is they take a look using clues in various things that we actually have here on Earth currently to see what was going on in climates in many thousands of years, and if not thousands, then tens of thousands, and even further beyond that, that long ago with the climates. We've only been able to record weather data for the last 200 years, couple hundred years, but we have other clues as to what the climate was like way longer ago than that. Okay, so for instance, one way to look is looking at trees. And I'm sure if you've ever seen a tree chopped down or a stump, you should know that the tree rings give us some information. Now, one of the things that people might know is the number of tree rings tells us every new tree ring represents one growing year. Okay, so as trees age, they add layers. Okay, kind of like layers of an onion, but they keep adding layers of wood under the bark. So every ring represents a new year. Okay, and so these layers are called tree rings. Okay, so if we take a look at a tree trunk, the outer part is the bark. And if you were to cross-section a tree, you would see these rings right here, these little lines that I'm drawing right there. Those are the growth rings. So they pile on every year. Right in the middle of the bark is the pith. And we've got other layers that we really don't need to worry too much about. Okay, what we do need to know, and this is why we're actually investigating it right now, is that we can kind of tell the history of the tree, what that tree has been through, by what the tree rings look like. Okay, because as we know, say there's a really hot season or a really dry season, that will affect how the tree would grow. Okay, and we can determine what kind of conditions those are by the size and color of those tree rings that are put on every year. So for instance, let's take a look at the thickness of our tree rings. So if we have a wide one, that is a good growing condition. So there was lots of rain, there was lots of sunshine, there was good stuff in the soil. Okay, so trees had it good. However, if there was a thin tree ring, that means not a lot was added from the last year. That means things weren't going so well. So whether there wasn't enough rain or sunshine or the soil was depleted for whatever reason, that kind of thing. Even if the tree caught some kind of disease, maybe in your neighborhood, I know in my neighborhood, like last year or the year before, they came and the city came and chopped down a bunch of ash trees because they were infected with a disease. Okay, so you may have noticed that too. So that's a lot of times what might happen. Okay, so let's take a look. Another characteristic is the color of growth rings. Okay, if we take a look at a ring that is very dark, that means the majority of the growth happened later on in the summer. So that indicates more of a slower growth because it didn't kick it into high gear until later on in the summer. If you have a lighter color ring, that means the majority of growth happened during springtime, which means it was kick-started early, and that generally means faster growth. Okay? Our shape of our growth ring, so you would think that a ring should be circular. And that's the ideal. If everything is like in a nice circle with no indentations or jagged patterns, everything was pretty consistent. However, if we have a ring that has like a distortion or it's thinner on one side, then that could be that the tree on that one side that was thinner was affected more adversely, right? So it could have been hit by something. It may have been like injured in some way. If you have black scars, sometimes that indicates fire damage. Why we actually take a look at tree rings is because they give us evidence, right? A lot of times trees have been around for a lot longer than we have. So they show us wet times, dry times, what else is happening, whether there was lightning or attacks by insects, that kind of thing. Okay, but the problem is that trees haven't been around for tens of thousands of years. Well, trees have, but individual trees haven't. Okay, so we can only monitor the lifespan of that tree. So that kind of thing. The interesting part, though, is say there's a tree trunk that is a residual in an archaeological site. That could give us information. Okay, so looking at how you would normally, because normally we would have a lab activity on this, this would be a tree ring activity. And so you would be asked, how old's the tree? And what you would have to do is you'd have to count every line. I'm not going to count every line, but in this case, it's 18 years old. You should have counted 18 lines. Okay. So is A the oldest or the youngest part of the tree? Well, it works its way out. So this is like the pith part, right? So this is the oldest part of the tree. If we're looking at B, it's a pretty wide tree ring. See, it's super wide. Let's see a lot wide. Oh, I realize that my answer is where C is, but that's what B is referring to. So it's a wide tree ring. So times were good for the tree at that time. Okay. C is fairly thin. Okay, so C is thin, and so that was less favorable, so less water, maybe not as many nutrients in the soil. And lastly, that dark black region that is indicated by D could be fire damage. All right, and here's a nice little video for you to watch at your leisure. Okay, so then we can also use things other than trees to take a look at maybe what past climates would be like. So fossils, and I'm sure you talked about this in geography. We've got sedimentary rock or sedimentary rock and fossils. So the sedimentary rock has stuff in it that's been deposited over time. Okay, and so it could be indicative of what was going on over long periods of time ago. All right, so sometimes color tells us information, and what type of minerals are depositive can tell you what was in the atmosphere at that time. Okay, fossils are remains of previously living things, so we often think of dinosaur fossils or other, like, organisms trapped in amber, kind of like Jurassic Park-esque. Okay, so we can get information about who was living, what organisms were living in a particular area at a particular time. Okay, so other clues could be footprints, leaf prints, fossilized dung, which you know what that means, right? So, but then they can tell from the fossilized dung or fecal matter, whatever you want to call it, they could see what the diet of those organisms were, because that would be in its waste. Okay, so for instance, if you find the fossil of a specific organism, in this case, tropical fish found in the rock of an Arctic island suggests that a long time ago, those tropical fish wouldn't be around in a cold atmosphere or a cold climate. So back in the day, way back when, that Arctic island would have had to be warm. Okay, moving on up. Ice cores. So think about it this way, where they're drilling and obtaining like a cylinder of ice from like a glacier. Okay, and that's what they do. They drill into glaciers, and those glaciers are trapped deposits of water that may contain air bubbles or things like that, or even different types of oxygen. And we're going to talk about isotopes in just a minute. But yeah, what they do is they like drill into a glacier, remove a core of ice. The deeper, or the bottom part of that ice core, is the older part of the glacier, because glaciers are also built in layers, kind of like the tree. Okay, so what you can find out when you drill these ice cores is you can see what's dissolved in the ice. So for instance, stuff from the atmosphere like dust, ash, salt, plant pollen. So all of those things are pretty characteristic. Maybe those plants from that plant pollen no longer exist. Ash sometimes tells us whether there was a volcano. Dust, well, what was floating around in the sky, that kind of thing. Okay, so that's what I was saying. Volcanic eruptions, meteorite impacts, whether there was a forest fire, and who was living around at that time. Okay, physical characteristics of ice. Now here's where my chemistry comes back into play. So ice obviously is frozen water, and the reason why ice is ice and ice can float is because packets of air are trapped between the molecules of the water when it's frozen. So you can actually figure out how the ice was made, and you could analyze the air within that ice. And sometimes ice is formed differently under different conditions. So the ice crystals look different when we have different characteristics of our climate. Okay, and I already alluded to this, trapped air bubbles in the ice. Once again, this is why ice floats, because there's air between the water molecules. Okay, so what they can do is actually analyze those bubbles to see what the air was like way back when. Lastly, the composition of the ice. Okay, so here's something, a little bit of chemistry. Back to my favorite. So we know that water is H2O, but what we don't know, or what we haven't really talked about in grade 10, is that a lot of our elements have these things called isotopes. And I'm going to start right there. And what an isotope is a variation of an element that has a different number of neutrons. Remember, we can't mess with the number of protons because that changes the identity of the element. But we can either have a nucleus that has more neutrons or less neutrons. So, and some of these isotopes can be medically useful, or they can be used in weapons. Okay, so you've probably heard of isotopes before. So that's what they are. And it's good to note that different isotopes of hydrogen and oxygen exist. And because their nuclei are different, they freeze and melt at different temperatures. So it kind of gives us a little bit of information of what the world was like at that time. Because if it froze at a higher temperature, you would know that overall the climate was warmer. Okay, so let's take a look here. Here's this situation. So if Earth is warm, there's lots more oxygen 16. If Earth is cold, oxygen, or my oceans become enriched in the heavier oxygen. Okay, so there's a bit of a situation here with our different isotopes, okay, of oxygen, and not so much hydrogen, but hydrogen in fact does have 3 isotopes that are commonly found on Earth. I'll let you know. We'll talk about that next year in grade 11 chemistry. Okay, to be continued on that. Anywho, here's a beautiful little video on ice cores. Once again, urge you to watch it at your leisure. And overall, what we're going to see is that climate change is a part of Earth's history. We have had fluctuations in our temperature. We've had ice ages. We've had times where desertification because things have been so warm. All right, so today, if you actually take a look, we're right here. There were times where the average temperature of Earth was way, way, way hotter. Okay, and if you take a look at my x-axis here, the time in millions of years ago. Right? So we're noticing a little upswing here, right? And people are like, okay, what's the big deal then with this climate and this global warming business? Well, if you ever had some time to kill, and this is something we would normally be looking at in class, there's a video called 6 Degrees Can Change the World, and I would love for you to watch it. It's a great video because it explains what each degree increase in global temperatures actually mean for society as we know it. Okay? And underneath here, and I don't know where my number 1 went, but I'm pretty sure it's on your page. Yeah, my number 1 is buried somewhere, but it'll be on your page. That's not on my video. Here are some questions that you can use to just verify that you understand what this lecture was about. As usual, there's an LMS quiz. Your last SNC LMS quiz that's regular. Now, the next thing we're going to do, so we are officially done the course as of right now. There will be a culminating LMS that has questions for all 4 units. It is open book. You have a couple of days to do it. Try your best. And if you have any questions or concerns, as usual, email me through LMS. You guys take care of yourselves, and I hope to see you soon. Bye.